Okay, so in this video, we're going to finish up the notes that we started on Tuesday. So we left off at number 8. We did the letters A and B. I just want to make sure that you guys get the correct values down for letters C and D. Okay, so C and D, these are both trig functions evaluated with angles that are in radians. We can tell that because there's no degree symbol. So in order to evaluate these correctly, your calculator has to be in radian mode. So when you find tangent of 1, if it's in radian mode, you should get 1.5574. For cotangent of pi over 5, there's some different ways you could do this. We don't have a cotangent button, but I would think to just do 1 over tangent of pi over 5. If you plug that in your calculator, you should get 1.3764. Okay. So now what we're going to do is we're going to use trig functions to solve for missing side lengths on a triangle. So for number 9, with this triangle, we have this angle of 48 degrees. We have the adjacent leg to that angle. This is the adjacent leg to the 48-degree angle is 20, and we want to find the opposite leg, which is x. So we need to write an equation that relates this angle with the opposite and adjacent side. So that is going to be tangent. So we are going to use tangent here. So we're going to do tangent 48 degrees equals opposite, which is x, over adjacent, which is 20. So now we just need to solve this for x. We'll do 20 times tangent 48 degrees equals x. So here our angle is in degrees, so either put your calculator back in degree mode, or you can use that special degree button that we learned about. So when you put this into your calculator, you should get 22.21. Okay. For the next triangle, we have a 31-degree angle. We have the x is actually the hypotenuse of the triangle, and 14 is the adjacent side with respect to that 31-degree angle. So we need a trig function that relates the adjacent and hypotenuse. So that is going to be cosine of 31 degrees. So cosine of 31 degrees is adjacent over hypotenuse, so it's 14 over x. So to solve this one, I'm going to multiply that x over, and then I'm going to need to divide by cosine of 31 degrees. When I plug this into my calculator, we get about 16.33. Okay. So these problems are a bit simpler, straightforward. You just make one equation that you can solve. Number 11 steps it up a notch. Okay, so for number 11, we want to find the value of x. So that is, x is the hypotenuse of this triangle. In order to be able to solve for a missing side length, I need an angle and at least one other side length, and I don't have that here. So what I'm going to have to do is I'm going to label this other hypotenuse of the first triangle as y. Okay, so we're going to need to find y first before we find x. And there's different ways we could do this. I've noticed that this first triangle here, the one I've labeled with pink, is a 30, 60, 90 triangle. So I know that this side, I'm going to use a instead of x, just so I don't have two different x variables. Side length would be a, this would be a square root of 3, and this would be 2 times a. So what I can do is I know that a times square root of 3 equals 50, which means that a equals 50 over square root of 3. If I know that that is a, then I know that y has to equal 2 times that. So it's going to be 100 over square root of 3. Okay. And now that I have my y value, I can solve for x. So y is the opposite leg to 65, that 65-degree angle. So I'm going to do opposite over hypotenuse. So that will be using sine. It's going to be sine of 65 degrees equals opposite 100 over square root of 3 divided by x. So to solve for x, I'm going to multiply x over, and then I'm going to divide by sine of 65 degrees. If you're asked for an exact value, this is it. We can plug that into our calculator, though, to get a decimal approximation. I'll give you a moment to work on plugging that into your calculator. We get about 63.704. Okay, so that one we had to do in 2 steps. So number 12 talks about what it means to solve a triangle. So we want to solve this triangle, which means find all missing sides and angle measures. Find all missing sides and angle measures. So here I'm missing sides A and C, and I'm also missing this angle B here. So I can actually find angle B just by knowing that the sum of all angles in a triangle has to be 180. So B is going to be 180 minus 90 plus 27, minus the sum of the other 2 angles. And this comes out to angle B is going to equal 63 degrees. Okay, so that's one of my missing values. I'm going to solve for A. You could solve for C or A. I'm going to solve for A. I'm going to use that angle of 27 degrees. And I'm going to do A and then the side length 18. So that's the opposite and adjacent. So I'm going to do tangent 27 degrees equals A over 18. So that means I have 18 times tangent of 27 equals A. So 18 times tangent of 27 is about 9.17. So that's my approximation. I'm going to keep the exact value in my calculator though, because what I'm going to do is I'm going to use that exact value of A with the side length of 18, and I'm going to use the Pythagorean theorem to solve for C. So I know that A squared plus B squared has to equal C squared. So A is about 19.17. I'll write the approximation on the paper, but in my calculator I will use the exact value I just got. Plus 18 squared equals C squared. So take a moment to solve that. And you will get that C equals 20.20, 20.20. Okay, so we've solved for the missing side length A, missing side length C, and the missing angle B. So we found everything that there is to know about this triangle. Okay, so the next problems, we're going to talk about how we can use this right triangle trigonometry in real-world problems. So when we talk about real-world problems, we use the terms angle of elevation and angle of depression. So this is all about line of sight, and if you have to look up at something or look down at something. So line of sight, looking straight forward, this is basically like your starting point or your 0 degrees. 0 degrees. If you have to look up at something, that's an angle of elevation. You're elevating your head. If you have to look down to see something, that's an angle of depression. It's a dip down. Here's a good example of this. This person standing on the road, if they're looking up at the window washer, angle of elevation. If they're looking down at the person sitting on the sidewalk, that is angle of depression. So it's all about line of sight. What is the horizontal here? Okay, so we are going to solve this problem. So we have a giant redwood tree that's going to cast a shadow that is 532 feet long. At that moment, the angle of elevation of the sun is 25.7 degrees. And we're going to find the height of this tree. Okay, so I have this pretty picture here, which you don't have, but what you can do is you can draw your own picture. This is really just a right triangle. You can draw a nice right triangle. Okay, we've got our tree here. We know that the distance or the length of the shadow is 532 feet. We don't know what the height of the tree is. That's what we want to find. And the angle of elevation, in this case, our horizontal is the ground. So you're looking from the ground up to the sun. That's 25.7 degrees. So if we're talking about angle of elevation of the sun or to the sun, you can assume it's from the horizontal of the ground. So we need to find the height of the tree. So we have an angle and we have one side length, which means we can figure out what h is. So I have the opposite and adjacent side, so I'm going to use tangent. So tangent of 25.7 degrees equals my opposite, which is h, over 532. I'm going to multiply 532 over. And I'm going to plug this into my calculator. We're going to get about 256 feet. Okay. All right, so our last problem is a little more involved here. So from a point on the ground 500 feet from the base of a building, an observer finds that the angle of elevation to the top of the building is 24 degrees, and that the angle of elevation to the top of a flagpole atop the building is 27 degrees. We're going to find the height of the building and the length of the flagpole. So again, you don't have the pretty picture, but you can just draw these triangles in. You can draw a little building with the flagpole on top. Okay. And we know we've got somebody on the ground 500 feet away. And when they look up to the top of the building, makes an angle of elevation of 24 degrees. If they look up to the top of the flagpole, I'm going to redo that line. Not much better, but that angle is 27 degrees. Okay, and then the picture that we have labels the height from the ground all the way to the top of the flagpole is K, and the height of the building is H. So we can solve for both H and K. H will give us the height of the building, which we want, and then we can subtract H from K to get the length of the flagpole. So solving for H, we're going to use tangent again. Tangent of 24 degrees is going to be H over 500. So I'm going to multiply 500 times tangent of 24 degrees. And we're going to get about 222.61. Okay, so that is the height of my building. And I'll just round to the nearest tenth. Okay. Now we want to find the height of the flagpole. So we need to find K in order to find this. So I'm also going to use tangent again. Tangent of 27 degrees is going to be K over 500. So we're using our other angle here. Multiply over the 500. And this is about 254.76. So this is not the height of my flagpole. To get the height of the flagpole, what you need to do is we need to subtract 222.6 from this K value. And when we do that, when we subtract 222 we get about 32.15 feet. Okay. So you all have an assignment to work on WebAssign. You can have the rest of class to work on it. I will expect you to scan in your work for this assignment. And you have a quiz on Friday, which would be tomorrow. So here for these notes, it was pretty arbitrary what I decided to round to on your homework, and on the quiz, it will be very clear for each problem. It will tell you how many decimal places to round to if it wants an approximation.